Next, let's move to the modern probability. We need to introduce random variable. Random variable, what's the definition of random variable? Because later we always talk about random variable X, random variable Y. Now what's the definition of random variable? A random variable is a mapping. So if I consider a random experiment with a sample space C, a random variable X, which assigns to each element C one and only one number. So this is a notation. X is a random variable. So this guy is a mapping. It maps the sample space to the real line. So you give me an element, I will give you a number. So this is called random variable. X is a random variable. The space or range of X is a set of real numbers. So this is a space or range. What are the possible values for this random variable? For example, I toss a coin. This is a random experiment. The possible outcomes for this random experiment is head or tail. I can define a random variable. For example, I can define if you get head, it's 0. If you get tail, it's 1. So this is a random variable. The possible values for this random variable is 0 and 1. You can talk about the probability. For example, what's the probability this random variable be 0? This is a chance. This is a chance when you get H, head. So it's half if it's a fair coin. So this is how you can define the probability related to this random variable. To characterize a random variable, there are some interesting and important functions. The first function, important function, is called cumulative distribution function, CDF. The definition of CDF, this is definition. Fx is probability x less than or equal little x. So you give me a little x, I give you a value. What is this value? This value is the probability x less than or equal to little x. So this is called CDF. So CDF is a non-decreasing function. So usually it's an increasing function. We have two types of random variables. Usually the first type is called discrete random variable. So discrete, that means this possible value is a countable set. So it's 0, 1, or integers. This kind of random variable is called a discrete random variable. Besides CDF, we can define a function called probability mass function, PMF, for this discrete random variable. So probability x equal to little x. So this is a PMF. Another type of random variable is called continuous random variable. Continuous random variable means this possible value is an interval of real numbers. For example, it belongs to 0, 1. This kind of random variable is a continuous random variable. We can define a function, it's called PDF, probability density function. So probability density function is a derivative of CDF. Now let me introduce some well-known discrete random variables. The easiest one is called point mass. So the point mass essentially is not a random variable, right? It's not random. It puts all its mass on a number. So this is point mass. Essentially x equal to c, right? You can define the CDF for this random variable. For example, by the way, for discrete random variables, the CDF is always a step function. So this guy, it is a step function. So this is C. So this is a CDF. This is 1. Okay. The next discrete random variable is discrete uniform. When you say uniform, that means the chunks are equal. So that means probability x equal to Cj is 1 over k. J equal to 1 over k. So that's a discrete uniform. So for this random variable, you can define the CDF, for example. It should look like this. So you have a jump 1 over k at each Cj. So this is a discrete uniform. There is another important random variable is called Bernoulli. You flip your coin. So the success probability is P. So that means Bernoulli random variable only can be 0 or 1. So head or tail. So probability x equal to 1 is P. Success probability is P. Probability x equal to 0 is 1 minus P. So that's a probability mass. So x follows a Bernoulli random variable. If x can be 0 and 1, the success probability is P. So there is one parameter P to define Bernoulli random variable. Binomial. Binomial, you flip your coin n times. How many heads you observe? So x follows a binomial distribution. So binomial x can be 0, 1 to n. It can be 0 heads, 1 head, or n heads. Now probability mass, probability x equal to little x. So this is n choose x, p to the x, 1 minus p, n minus x. So this x can be 0, 1 to n. So this is PMF for binomial random variable. You can verify this is a valid PMF. You can take the sum. N choose x, px, 1 minus p, n minus x. X from 0 to n. This is a binomial sum. So this is p plus 1 minus p to the power n. This is 1. So the total mass is 1. So this is a valid PMF. This is a binomial distribution. Geometric distribution. So geometric distribution means what? The number of flips you need to see ahead when flipping a coin. The number of heads you need to see the first head to flip your coin. So this x can be 1, 2, all integers. Now probability x equal to little x. So this is p, 1 minus p, x minus 1. So this is head. This is tail. You have tail, 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 head. So this is geometric distribution. Now another discrete random variable is called Poisson distribution. So Poisson distribution has a parameter lambda. Now Poisson distribution x can be 0, 1, 2, or non-negative integers. Now probability x equal to little x. This is e to the lambda, lambda to the x, x factorial. So this is called Poisson distribution. So Poisson distribution, you can easily to verify how this is a valid PMF. You can take a sum. E to the negative lambda, lambda to x, x factorial, x from 0 to infinity. So e to the negative lambda, lambda to x, x factorial. This is a Taylor expansion of e to the lambda. So it is a valid PMF. The Poisson distribution is often used to model the counts of real events. So it's a count 0, 1, 2, 3. You can say what's the probability, how many insurance claims in this month. What's the probability, the claim number is 5. You can calculate the probability. Once you know lambda, of course. Now there's some well-known continuous random variables. First one is called a uniform. So for continuous random variable, if it's uniform, that means PDF is a constant. So fx is a constant. So this is 1 over b minus a. X is between a and b. 0 otherwise. So this is a, b have constant. This is a PDF. If you do integration, it must be 1. You can calculate CDF by integration. This is called a uniform. Now, if you do CDF, fx 0, x less a, x minus a, b minus a, x is between a is 1. x is greater than b. So the CDF will look like 0, linear, 1. Hold on. So this is A, this is B. So less than A is 0, linear, 1. So that's a CDF. Exponential distribution. So X follows the exponential distribution with the parameter beta. So the PDF, we talk about continuous random variables now. The PDF is 1 over beta e to the x over beta. So exponential distribution is non-negative, 0 otherwise. That's an exponential distribution. Normal. So normal is the most important distribution in probability in statistics. So X follows a normal distribution. The normal distribution has 2 parameters, mean and the variance, mu and the sigma square. So normal distribution, the PDF, is 1 over square root of 2 pi sigma square e to the negative 2 sigma square x minus mu square. So normal random variable can be anything, x between negative infinity to plus infinity. The CDF is a bell shape. So it's symmetric around mu. Now the sigma square controls the spread out. So this is larger sigma square. This is smaller sigma square. So this is normal distribution. The normal distribution is the most important distribution.